We're still on chapter 26, and this particular talk is on renal regulation. So, chemical buffers cannot eliminate excess acids or bases from the body. The lungs eliminate volatile carbonic acid by eliminating CO2, and the kidneys eliminate non-volatile or fixed acids produced by cellular metabolism to prevent metabolic acidosis. Kidneys also regulate blood levels of alkaline substances and renew chemical buffers. Kidneys regulate acid-base balance by adjusting the amount of bicarbonate in the blood by either conserving or generating new bicarbonate or excreting bicarbonate. Generating or reabsorbing one bicarbonate is the same as losing one hydrogen ion. Excreting one bicarbonate is the same as gaining one hydrogen ion. Renal regulation of acid-base balance depends upon the kidney's ability to secrete or retain hydrogen ions. To reabsorb bicarbonate, the kidney must secrete hydrogen. To excrete excess bicarbonate, the kidney must retain, not secrete, hydrogen. To maintain the alkaline reserve, the kidneys have to replenish bicarbonate. And tubule cells are impermeable to bicarbonate. However, they are permeable to carbon dioxide. And so bicarbonate ends up back into the body in a roundabout way by being converted to carbon dioxide. Once back into the cell, the carbon dioxide can be converted back into bicarbonate, or it can leave the cell as carbon dioxide. The mechanism is coupled to hydrogen ion secretion. For every hydrogen ion secreted, a bicarbonate is reabsorbed. This is the mechanism. This is like the process, the steps that it goes through. I'm not going to ask you any questions about this. I'm not even going to go over it, but I wanted you guys to at least see that it looks a lot more complicated than it really is. But you don't need to know. Then we're going to talk about generating new bicarbonate ions. So the metabolism of food is going to generate new hydrogen ions that have to be balanced by generating new bicarbonate. Secreted hydrogen used to reclaim filtered bicarbonate is not really excreted from the body. It's actually incorporated into a water molecule, which can be reabsorbed. So the body has the same number of bicarbonate and hydrogen ions that it started out with. There are no net gains. There are two mechanisms in the proximal convoluted tubule and type A intercalated cells that generate new bicarbonate by ridding the body of hydrogen ions. This is via excretion of buffered hydrogen ions or via ammonium excretion. So first we look at the way that it would be via excretion of buffered hydrogen ions. So as you may remember, the most important urine buffer is the phosphate buffer system. Intercalated cells actively secrete hydrogen ions into the urine, which is buffered by phosphates and excreted into urine. And then new bicarbonate is generated in the process and moves into the interstitial space via cotransport, and then it moves passively into the peritubular capillary blood. So what we have here, we have cursor. Where's my cursor? Ah, there we are. Okay, carbon dioxide here combines with water, and it's going to form carbonic acid. This gets split into a hydrogen ion and a bicarbonate. The bicarbonate is going, well, first we'll look at the hydrogen ion. The hydrogen ion is going to be secreted into the filtrate by an hydrogen ATPase. So there we go, into the filtrate. And the bicarbonate is going to enter the peritubular capillary, which is what this is happening here. The secreted hydrogen ion is going to combine with this right here, a phosphate, and it is going to form this, and it's excreted out of the urine, out in the urine. The other mechanism is via ammonium excretion. This is a more important mechanism for excreting acid. It involves metabolism of glutamine in proximal convoluted tubule cells. Each glutamine produces 2 ammonium and 2 new bicarbonate. The bicarbonate moves into the blood and the ammonium is excreted in urine, and this is going to replenish the alkaline reserve of blood. So we have, here we go, glutamine. It gets split into 2 ammonium and 2 bicarbonate. The bicarbonate passes out, goes into the blood. The ammonium is put into the filtrate and it's excreted out in urine. When the body is in alkalosis, so we've been talking more about acidosis, but if the body is in alkalosis, type B intercalated cells can secrete bicarbonate and reclaim hydrogen ions to acidify blood. The mechanism is opposite of bicarbonate ion reabsorption process by type A intercalated cells. Even during alkalosis, the nephrons and collecting ducts conserve more bicarbonate than they excrete. Here is your, that should say question, not questions. And that's all I have for you for this talk. Have a wonderful day.